Space missions. Exercise. Q. 1. Fill in the blanks and explain the statements with reasoning. A. If the height of the orbit of a satellite from the Earth's surface is increased, the tangential velocity of the satellite will be the initial velocity during launching of the Mangalyaan must be greater than of the Earth. Answer. If the height of the orbit of a satellite from the Earth's surface is increased, the tangential velocity of the satellite will decreases. Explanation. As tangential velocity of satellite is inversely proportional to the height of orbit of satellite from Earth's surface. V equals. Where V equals tangential velocity. G equals gravitational constant. M equals mass of Earth. R equals radius of Earth. H equals height of satellite above Earth's surface. B. The initial velocity during launching of the Mangalyaan must be greater than escape velocity of the Earth. Explanation. Spacecrafts should escape the Earth's gravitational force to travel to outer space. Escape velocity is the minimum speed required by an object, i.e. satellite, to escape from the gravitational force of the Earth. The minimum velocity of satellite should be 11.2 km/s. Q. Though. State with reasons whether the following sentences are true or false. A. If a spacecraft has to be sent away from the influence of Earth's gravitational field, its velocity must be less than the escape velocity. B. The escape velocity on the Moon is less than that on the Earth. C. A satellite needs a specific velocity to revolve in a specific orbit. D. If the height of the orbit of a satellite increases, its velocity must also increase. Answer. False. Explanation. Spacecrafts should escape the Earth's gravitational force to travel to outer space. Escape velocity is the minimum speed required by an object, i.e. satellite, to escape from the gravitational force of the Earth. So its speed should be more than the escape velocity. B. True. Explanation. The mass of Moon is less than the mass of Earth, so its gravitational pull is less, hence escape velocity on Moon is less as compared to Earth. C. True. Explanation. A satellite requires a specific velocity to revolve in a specific orbit called critical velocity, which acts as a tangential direction to the orbit. D. False. Explanation. If the height of the orbit of a satellite increases, its velocity decreases. As tangential velocity of satellite is inversely proportional to the height of orbit of satellite from Earth's surface. V equals. Where V equals tangential velocity. G equals gravitational constant. M equals mass of Earth. R equals radius of Earth. H equals height of satellite above Earth's surface. Q. 3. A. Answer the following question. What is meant by an artificial satellite? How are the satellites classified based on their functions? Answer. A man-made object revolves around the Earth or any other planet in a fixed orbit is called an artificial satellite. Based on their function, satellites are of various types. A. Weather satellite, study and prediction of weather. B. Communication satellite, establish communication between different locations of the world. C. Broadcast satellite, telecasting of TV programs. D. Navigational satellite, fix the location of any place on the Earth's surface. A. Military satellite, collect information for security aspects. F. Earth observation satellite, study of forests, deserts, oceans, polar ice at sea. Q. 3. B. Answer the following question. What is meant by the orbit of a satellite? On what basis and how are the orbits of artificial satellites classified? Answer. An orbit is a regular, repeating path that satellite takes around the Earth to revolve. Depending on the height of the satellite's orbit above the Earth's surface, the orbit of satellites are classified as follows. I. High Earth orbits. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 kilometers, the orbit is called high Earth orbit. These satellites almost take 24 hours to complete one revolution. These are also called geosynchronous satellites. They are used in meteorology, carry signals for telephone, TV, radio etc. Medium Earth orbits. If height of the satellite orbit above the Earth's surface is in between 2000 km and 35,780 km, the orbits are called medium Earth orbits. Low Earth orbits. If the height of the satellite orbit above the Earth's surface is in between 180 km and 2000 km, the orbits are called low Earth orbits. They are used for scientific experiments and atmospheric studies. Q. 3. C. Answer the following question. Why are geostationary satellites not useful for studies of polar regions? Answer. Geostationary satellites' orbit is above the equator, so they are not useful for studies of polar regions. Q. 3. D. Answer the following question. What is meant by satellite launch vehicles? Explain a satellite launch vehicle developed by ISRO with the help of a schematic diagram. Answer. Satellite launch vehicles are used to place the satellites in their specific orbits. The function of this vehicle is based on Newton's third law of motion. ISRO has developed PSLV Polar Satellite Launch Vehicle. It consists of an engine which uses solid fuel that provides initial thrust, which provides certain velocity and takes it to certain height. There are 4 stages which uses solid and liquid fuel alternatively. Once the first stage fuel is used up, the engine and first stage gets detached from the main body and falls into sea or unpopulated land. The weight got reduced and it moves with more high speed. Once the fuel in first stage is exhausted, the fuel in second stage is ignited and so on. Q. 3. E. Answer the following question. Why it is beneficial to use satellite launch vehicles made of more than one stage? Answer. The fuel forms a major portion of the total weight of the launch vehicle, so vehicle has to carry a large weight with it. So to overcome these problems, launch vehicles are made up of more than one stage so that the fuel in the stage, when exhausted, it gets detached from the main body step by step and weight is reduced so that it can move with high speed. Q. 4. Complete the following table. Answer. IRNSS. Fix the location of any place on the Earth's surface in terms of its precise latitude and longitude. Navigational satellite. INSAT. GSAT. Weather study or predict. Weather satellite. IRAS. Study of forests, desert, oceans, polar ice on Earth's surface. Earth's observation. Q. 5. A. Solve the following problems. If mass of a planet is 8 times the mass of the Earth and its radius is twice the radius of the Earth, what will be the escape velocity for that planet? Answer. Mass of planet M equals 8x mass of Earth equals 8 by 6 by 1024 kilograms. Radius of planet R equals 2x radius of Earth equals 2 by 6, 4 by 106 meters. G equals gravitational constant equals 6.67 x 10 minus 11 nm22. So escape velocity equals escape velocity 22.4 km/sec. So escape velocity of the planet will be 22.4 km/sec. Q. 5. B. Solve the following problems. How much time a satellite in an orbit at height 35,780 km above Earth's surface would take, if the mass of the Earth would have been 4 times its original mass? Answer. Given g equals gravitational constant equals 6.67 x 10 minus 11 nm22. M mass of Earth equals 4 by 6 by 1024 kilograms. R equals 6400 kilometers. H equals height of satellite above Earth's surface equals 35,780 kilometers. R jor H equals 6400 plus 35,780 equals 42,180 kilometers equals 42,180 by 103 meters. V know V equals 6.16 kilometer प्रति second. We know V equals distance time, circumference time, 2 pi RT. T equals 43,001.68 seconds. T equals 11.94 hours or approximately 12 hours. Q. 5. C. Solve the following problems. If the height of a satellite completing one revolution around the Earth in t seconds is h1 meter, then what would be the height of a satellite taking 2 to t seconds for one revolution? Answer. Given the height of the satellite completing one revolution around the Earth in t seconds, let the height be x of a satellite taking 2 to t seconds for one revolution. From Kepler's third law of motion, the square of the time period of revolution of the planet around the Sun is directly proportional to the cube semi-major axis of its elliptical orbit. Tr3/2. Where t is the time period, is the radius of the satellite, thus we can say, t equals kr3/2 I. Here, r1 equals r when t1 equals t. We get, then, if t2 equals to 2. Putting the value in the equation I, we get 2t equals kr1 3/2. Putting the value of k in the above equation, we get. On solving the above equation, we get squaring both sides and then taking cube root, e. Now r1 equals r jor x, radius of Earth jor height above Earth, and